Is that right?
My dad's like,
Yeah.
yeah. I can't sit, I can't coach. It's over.
He doesn't even care. He just cares about
He doesn't care if I get sick. He's like,
Okay. Hi, everybody. My plan here for today is I want to finish talking about factoring and do a couple of examples, and then we're going to spend the rest of our time in class just working on the assignments. Okay, so probably about 15 minutes of me talking, and then you guys can have the remainder of the time to work on these homework assignments. I know that this is kind of getting to the hectic time of the year where things start stacking up and everybody kind of loses some oomph. So I'm going to try to help you out here and give you a little bit of time to take care of things here in school.
I bought a mask with hats on it.
Just to really lay it on thick for your parents. I know, I've heard.
That scared me. Maybe you should have more. Yeah.
There is.
Kelly, are you just not satisfied with your dog?
No, I am, but she was a cat friend.
She hates it.
All right.
She lived with us.
So I'm going to kind of run through this factoring process with a couple of examples here, and then I'm going to release you guys to work on the assignments, okay? All right. So let's say we want to factor x squared minus 2x minus 35. Can we stop talking, please? So I'd like to start by identifying the values for a, b, and c. When I say a, b, and c, I'm talking about the coefficients from our standard form polynomial. Okay. So in this case, what's our value for a? 1. What's our value for b? -2. And what's our value for c? -35. Is everybody good with how we figured those out? Okay. So the next thing I need to do now is I need to find the two numbers that multiply to give me a times c. So in this case, 1 times -35 or -35, and then add to give us b. So in this case, -2. To do that, we're always going to start with the multiplication problem. So we're going to find an answer to the multiplication problem and see if it also satisfies the addition problem. Okay. Oops. So what's a pair of numbers that multiply to give us -35? So I heard 7 and -5. So those multiply to give us -35, but they don't add to give us +2 or -2. They add to give us +2. So let's switch the signs. -7 and +5. That works. So those are my two numbers that I need. Everybody's okay with that? What we're going to use those two numbers for is we're going to rewrite the original problem, but instead of writing 2x or -2x, I'm going to write -7x plus 5x. Notice that that is still the same as, oh my. Notice that's still the same as what we had before, right? Because -7x plus 5x is still -2x. I haven't really changed anything. I just wrote it in a different way. So far, so good? Okay. So what I'm going to do now is I'm going to make two groups. I'm always going to make sure I have an addition symbol in between my two groups. And then from that first group, I'm going to look for a greatest common factor. So the greatest common factor between x squared and negative 7x is, what's something that divides both of those? X, right? Everybody's okay with that? So I'll factor that x out front, and to find out what goes inside, I'll take x squared and divide it by x, which gives us just x. And I'll take negative 7x and divide that by x, which gives me just negative 7. You can always check to make sure you did that correctly by distributing back through and making sure you got the same thing that you started with. Now I'm going to look at the second group, and I'm going to look for a greatest common factor in that group. So what divides both 5x and negative 35? 5. 5x divided by 5 is just x, and negative 35 divided by 5 is negative 7. So far, so good. Now I'm going to look at each of these as its own separate thing. And I'm going to look for a greatest common factor between them. What's the greatest common factor between these two? It's just x minus 7, right? Each of them contains a factor of x minus 7. So when I factor that off, I'm left with x and plus 5. And there's my factored form. Questions on what I've done here? We're going to do some more, but I just wanted to run through an example here to start. Eventually, we're going to cut down on the amount of work that I want you to show, but for right now, until I tell you otherwise, I'm going to expect to see that you guys have wrote out this part and you're doing this part. Eventually, we'll kind of shorten this up a little bit, but right now I think it's important that we're doing all of those steps. Let's do another example. So let's say we do 10x squared minus 23x plus 12. So we'll start by writing down the values for A, B, and C to start with. What's my value for A? 10. What's my value for B? Negative 23. And my value for C is 12. So then I need to find the two numbers that multiply to give me 10 times 12, or 120, and add to give us negative 23. Now here it's not quite as easy as the previous one, because 120 isn't necessarily like a times table problem or times table number. So what I would do with this is I would just approach it kind of exhaustively. Oops, that's positive 120. So I'll start with the things that multiply to give me 120. I'll start with the most obvious one, 1 and 120. Well, clearly those don't add up to give me negative 23. Now I did two positives. Those multiply to give me a positive. But I also know that two negatives multiply to give me a positive. And since those numbers need to add up to give me a negative, I'm pretty sure that I'm going to need to be checking two negatives. But again, those don't add up to negative 23. They add up to negative 121, which is too big. Okay, so maybe now I do 2 and 60. That still doesn't add up right. Neither does negative 2 and negative 60. So let's do 3 and 40. That multiplies to 120, but it doesn't add up correctly. Neither does negative 40. How about 4 and 30? Still doesn't add up to be the right thing for the negatives. 5 and 24. Nope. Negative 5 and negative 24. Nope. 6 and 20. Nope. Negative 6 and negative 20. Nope. 7 doesn't divide 120, so I can skip that. 8 and 15. Or negative 8 and negative 15. That's the one that I need. That adds up to give me my negative 23. So it took a while to get there, but I went systematically, so I knew that I couldn't miss the number if I got there, but it would have, by just guess and checking, it would have taken a while to get to 8 and 15, or negative 8 and negative 15. But if you just kind of go systematically, taking each pair of possible factors and just keep working till you find it, you'll find it. Is that okay? So now that we found our two numbers, we're going to go back to the original problem. And we're going to rewrite this as x squared minus 8x minus 15. Plus 12. So again, I just rewrote negative 23 as the sum of those two numbers. Now, we didn't ask this question before, but let's ask it now. Does it matter what order I put the negative 8x and the negative 15x in? No, it doesn't matter. You'll get the same answer. Like, your factors might be in a different order, but that doesn't matter because we're multiplying anyways. So it doesn't matter which one you put where. So I'll make two groups then. And I'm going to look now for my greatest common factor. So what's the biggest thing that we can divide from 10x squared and negative 8x? 2 is the biggest thing that we can divide between 10 and 8. But you also have to worry about the x squared and the x part. Yeah. So 2x is what we want there. So 10x squared divided by 2x. 10 divided by 2 is 5. And x squared divided by x is x. 2 divided by 8 is 4. And x divided by x just kind of cancel out. Now let's look at the next group. Close. I would do negative 3. Let's see why negative 3 would be important here. So negative 15x divided by negative 3 is positive 5x. And positive 12 divided by negative 3 is negative 4. Notice that if I didn't take a negative 3, these two parts wouldn't be the same, and we'd be stuck at the next step. So because I knew what I was looking for, 5x minus 4, I knew on the second part I was going to need a negative 3 rather than a positive 3. Is that okay with you? Okay. So now I notice that there's a 5x minus 4 in common. So if I factor that out, I'm left with 2x minus 3. And we're done. Is that okay with you guys? So the hardest part, or maybe the most time-consuming part, is going to usually be the finding the two numbers, right? After that, it's really the same length from there on out. Do we feel okay about this factoring process? Okay. Well, we're going to stop here then. That's what we wanted to do for today. So if you guys feel good about